Hey students, this is lesson 421. In these lessons, we're going to learn how to identify and describe examples of exponential growth and decay. And we're going to learn how to represent exponential growth and decay relationships with algebraic expressions and equations. All right, so we're going to introduce you to a situation that involves exponential, actually decay. Decay means it goes down. And that is a super ball dropped from a height of 10 feet. Each time it falls, it rebounds 3/5 of the distance that it fell. List the heights of the first 4 rebounds. A table would be handy here to list the heights. So I'm going to a table here. And I'm going to list the first 4 heights. I'm going to use a calculator too to help me here. So, all right, so one of our variables is rebounds, and that's going to be our independent variable, or x. And our other variable is the height, and that's going to be our dependent variable, or y. And we're going to go up to 4 rebounds. And our first rebound, or our 0th rebound, that's where we initially dropped it from, so where we started from, and that's 10 feet. And then to get our first rebound, we need to have 3/5 of that, because it rebounds 3/5 of the distance. Like if it rebounded half the distance, that would be 5, 10 divided by 2, or 10 times a half. So we need to multiply 10 times 3/5 to get 3/5 of the height. And that equals 10 times 3 is 30, 1 times 5 is 5, 30 divided by 5 is 6. Okay, on our second rebound, we're going to rebound 3/5 of that distance. So a part of that distance, I'm going to use my calculator to get the rest of these now. And kind of take note how I do this. You're going to be doing, so the 0th rebound is 10. I'm just going to enter that. Then we're going to multiply by 3/5, and I'll just use the divide symbol to do that. So multiplying by 3/5 once is 6. And then if I hit enter, multiplying that by 3/5, I get 3.6, 2.16. And then the 4th rebound is 1.296. Let's just round that to 1.3. All right. And that's how you can use a calculator to help you get an exponential relationship. Notice I just kept multiplying by 3/5. So, and just thinking about that for a second and trying to establish what expression would represent this. On this 4th one here, we started with 10 at 0, and I multiplied by 3/5 each time. And it turns out the number of times I'm multiplying by 3/5 is the same as the number of rebounds. Each rebound you multiply by 3/5. Notice I'm multiplying by the same thing. That suggests an exponent, or the expression for the 4th rebound would just be 10 times 3/5 to the 4th power. And in general, any rebound, so let's say I just kept going, the nth rebound would just be 10 times 3/5 to the nth power. So we just need to multiply 3/5 by however many rebounds we have. All right, let's look at another situation that's exponential here. Suppose you make up a funny joke one evening, the next day you tell it to 2 classmates, the day after that you'll have 2 classmates each tell it to 2 people. Everyone who hears the joke tells 2 new people the next day. On the 4th day after you made it up, how many people will hear the joke? So we need to follow this pattern out 4 places. Again, a table would work pretty good for this. So I'll just make a table here. And again, we need 4 days. Move this down a little, give me a little more room. right? All right. So, so we have the days. This is days after we told the joke, and then this is the number of new people who heard the joke. So, on the 0th day, that's when you made up the joke. One person heard that, and that was yourself. On the first day, you told that to 2 new people. So there's 2 more. Now this is new people, not the total. You'd have to add up all these to get the total. On the second day, each of these 2 people told it to 2 people. So that's 2 times 2 is 4. And then on the next day, each of these 4 people told it to 2 people. So 4 times 2 is 8. And so we can see a pattern now. I'm just multiplying by 2 each time. And so the next one would be 16. And what you might notice is that the number of days is the same as the number of times I multiply by 2. So, so we can write an expression to represent this as 2 to however many days represents how many people have heard this. So this question says, on which day will more than 1,000 people hear the joke? I'm going to let you try and figure that out, and you can share that in class the next day. And then the next question says, if the joke was told to people in your school, how many days would it take for everybody in your school to hear it? And I'll just tell you that there's 1,400 people. All right, and then I'm going to move on to this fish problem here. It says Marcus has 3 fish in an aquarium. Each week, the number of fish in the aquarium doubles. The chart shows the number of fish Marcus has after each week. So it says they're doubling, and you can see that here. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. It says by what number do you multiply to get from one number of fish to the next? So doubling is multiplying by 2. And since we're multiplying by 2, we can represent this with an expression. Like, let's say we wanted to find one more here. Let maybe the 10th week out here. And we notice that we're multiplying by 2 for every week. So I need to multiply by 2 10 times to get the 10th week, and I'm starting at 3 fish. So an expression for the 10th week would be 3 fish in the first times 2 for each week, and then to the 10th power, so I multiply by 2 10 times. And that equals 3 times 1,024, which is 3,072 fish. And in general, we can find any week, so n, just by taking the number we started with times 2 to the nth power. All right, I'm going to do one more problem with you. And that's this problem right here with the bacteria. It says, for a science experiment, Tanya puts 1 amoeba in a dish, 1 amoeba. Each day she counted and recorded in a table the number of amoebas in the dish. So day 1, 1, day 0, 1, so she started 1, day 1, 6, day 2, 36, and so on. How does the number of amoebas change each day? Well, I know 6 times 6 is 36, and 1 times 6 is 6, and 36 times 6, I'm going to guess, is 216. So we are multiplying by 6. So the bacteria is multiplying by 6 each day. So which expression describes the number of amoebas? Well, notice that we are continually multiplying by 6. And the expression that continually multiplies by the same base of 6 is this one here, 6 to the x power. How many amoebas will be in the dish in day 6? To figure that out, notice in day 3 we have 216, which is multiplied by 6 3 times. So on day 6, we're going to multiply by 3 or by 6 times, because our x stands for how many days. So 6 to the 6 equals, and we're going to need a calculator for that one. 6 to the 6th power is 46,656. All right, we'll work some more on these next time we meet in class. Go back and finish that one problem I skipped over, and we can talk about that in class, this problem right here about the number of jokes told. How many days will it take for 1,000 new people to hear the joke? All right, we'll see you later.